The broadcast is now starting. All attendees are in listen-only mode.
Welcome to Eccentric Mold and Engineering's webinar. If you are here for our common plastic injection molding design challenges, you're in the right place. I'm Connie, and I'll be your host for this session. A few things to cover before I turn the webinar over to our keynote speakers. This presentation is expected to last approximately 30 minutes. Q&A is included during the presentation, so feel free to submit your questions along the way with us using the chat function located in the lower right-hand corner of your control panel. If we run out of time, before all the questions are answered, we'll follow up with you by sending you an email containing those answers. With that, I now turn over the webinar to our keynote speakers, John Sidorowitz, Glenn Miller, and Darwin Rowe. Gentlemen, please tell us all a little bit about yourself.
Good afternoon, everyone. My name is John Sidorowitz. I'm VP of Inside Sales and Customer Service here at Eccentric. I've been with the company about 8 years and 15 years in injection molding. Glenn?
Hi, everybody. This is Glenn Miller. I'm a tooling engineer at Eccentric. I've been in plastic injection mold design for over 25 years. Looking forward to our webinar today.
Darwin?
I'm Darwin Rowe. I've been with the company for about 3 months now. I have 25 years of building tools and as a background.
All right. Again, welcome, everyone. Today's webinar, we're going to touch on these topics here, and it's going to kind of be a Q&A, so feel free to ask questions on each topic. We'll try to get to them after we finish each topic, and of course, if something comes up between now and the end, we'll try to get to those questions at the end. So let's get started. So when designing your plastic part, you want to take into account your wall thickness. You want to maintain uniform wall thickness throughout your design. You want to core out any unneeded thick sections or wall stock. Use ribs, stiffening features, any supports that provide an equivalent stiffness with less wall thickness. What this is going to do is allow material to flow better throughout the part, create an even shrink throughout the part, and obviously reduce costs in material and cycle times. We've got a little table there off to the right. You can see kind of some recommended wall thicknesses for different materials, and just take note of that different materials require different wall thicknesses. But the biggest thing, again, is just maintaining a uniform wall thickness throughout your part.
And one of the John mentioned coring out unneeded wall thickness. A lot of times we'll see thicker sections of plastic will create sink marks due to the thicker wall section. So that's also something to consider. Another reason to eliminate any unneeded thick areas on your parts.
And another thing to add, if some parts obviously can't be designed with a nominal wall thickness, and when you do have thick to thin or thin to thick transitions, it's make sure you're designing them correctly, and we're actually going to touch on that next. Just getting material to flow from the thin section to the thick, and we'll go in there. Darwin, you want to add? No. Okay. All right. So as I mentioned, kind of your transitions. So we kind of group these together, RADS and transitions.
Yeah, I mean, anytime you have a part, what you want to avoid are, if at all possible, any sharp corners. Sharp corners and plastic flow don't go well together generally. So anytime you can add radii to any of the sharp corners or some sort of rounded flow feature, that's going to help with the fill. It's also going to help with the strength of your part, not having a sharp corner. A sharp corner is a stress location for potential damage to your part. But yeah, I mean, anytime you can add a radius to any sharp corner, that's always a good design detail that you want to think about when you're designing your parts. Anything else there?
From a tooling aspect, you're going to want your outside radiuses to be as large as you can possibly get to, just so it's an easy build.
That's true.
To go back in and pick little corners out, the bigger you can get it, the better it will be for speed, for
right?
Quick turnaround. And
The finer the detail, the more times you may have to go in and do an EDM burn to get a sharp corner in there, when instead you could just use a cutter.
And you're reducing material too.
Exactly.
And again, if you guys have questions, feel free to ask them. We'll kind of answer them as we go. And then we can save them to the end. The next topic is going to be draft. And this is a pretty important one. Just making sure your parts are designed with draft to prevent any type of sticking or ejector pin push. If you have zero draft on the inside, it's going to be difficult to eject that part off the tool. And vice versa, if you have zero draft on the outside and getting stuck into your cavity side, essentially stuck in the tool. Here at Eccentric, we try to keep to a minimum draft requirement of about a half a degree. It should fit most applications, but depending if it's a long draw part or something like that, or if you've got a heavy texture or bead blast on the outside, you may require a lot more. Typically 3 to 5 degrees of draft is required.
That's it. I mean, it really comes down to being able to eject this part out of your tool and or not have it stick to the cavity side of it. So anytime you can add as much, as from a tool guy point of view, anytime you can add draft, more is better. We do realize that some parts you want to keep your walls as straight as possible, but there needs to be some amount of draft in this tool for it to have any chance of functioning in the mold.
then you got to keep in mind too, if you keep your wall straight, you increase your chance of having like a drag mark on your back and the side walls. So your aesthetics aren't going to be what you're looking for.
Right. And not to say that parts can't be made with zero draft. Some designs need that, and it can be made, but there's different things that we can do with the tooling, specialty coatings on cores that help with the release of the part. But as a whole, try to add as much draft as you can where you can.
All right, next up on our list is threads. For the most part, threads are originally, any thread that was originally designed for a metal to metal application may not be suited for a plastic thread. For instance, very tiny threads it's difficult to mold. A lot of times our customers will use molded in inserts to create the smaller threads in their parts for assembly. Always a good practice for that. And as your threads get larger, the main thing with threads, you want to go a plastic male into a female that's metal. Going the other way around, usually you have issues with fit, leakage, or just not a nice tight thread. Also, with plastic threads, we tend to require less sharpness in the threads, just due to the plastic. Issues with the fit on the threads, what we run across sometimes, if you have a parting line across your threads, that's a location where any extra plastic that gets in there is going to create an issue with the assembly to the other half. So those need to be kept clean. If at all possible, you want to avoid a seam line across your threads. A lot of times that's not possible. There are other ways to take care of that.
Yeah, but by rounding off those threads should compensate for that.
Exactly, and it strengthens the threads. Sharp
Right.
corners aren't usually good in a plastic thread.
Yeah, so you're going to design your plastic threads, either female or male threads a little bit differently than you would do, metals. Metals are going to have sharp corners, sharp edges. With plastics, everything's going to be rounded. Adding RADS, as you kind of see in the small picture to the right there, the crests are rounded, the roots are rounded. It's just going to allow for better material flow and account for any parting lines or anything like that when you're threading into the mating set of threads. The other one. Okay. This isn't really a challenge, so to speak, but a lot of people are trying to do two-shot, combining two materials to save on assembly and try to get two different colors or aesthetics. With overmolding, the big thing isn't necessarily a design challenge, but it's more so material selection, making sure the two materials go together. Now, you can have materials that will work together, but they may not create a chemical bond, so that's where you have to come up with mechanical bonds. Kind of like what we do on the left-hand side there. You can see the first, the green part, which we call the substrate. It has some windows or pass-throughs. So when we do overmold the black rubber kind of dial feature, it actually flows through those windows and actually locks onto the part, so it won't come off. So when you're designing a part that's for overmolding, kind of keep that in mind, making sure materials are going to work together and they're going to stay together.
And your material suppliers, obviously, you can pull them in. They're a good resource to understand what materials are good for bonding, for overmolding, and if you have a rubber material overmolded onto a plastic, they can definitely help you out with the materials that work well together and ones that don't, and help you make a selection that way.
Okay.
I would definitely go with material pad when you're designing this up. Get his recommendations.
Okay, looks like we do have one question. Will we be able to have a copy of this presentation afterwards? Yes, it'll be sent out within, I believe, 48 hours of today's webinar.
Yes, and you can also, if you like, we can send it to you directly through sales@eccentricmold.com. Just send that to us, and we'll be happy to forward that over to you.
All right, looks like we got another question here. How to ensure good flow mixing of fiber impregnated plastic when plastic flows around a feature, specifically a hole?
A lot of times, specific filled materials require a certain heat or certain processing to assure that the fibers are embedded in the plastic part. That's definitely something you have to look out for, and when your operators are running these tools, make sure that they're following the guidelines set forth by the material spec sheets.
Okay. So we got another question here. How about if you overmold a TPE onto another TPE? I mean, it's really going to come down to design. If you're trying to overmold over a thin part of, or a thin wall of TPE, it may just, I don't know what the word is. It may not work. It would really come down to design.
You might not get a good bond between those two parts being the same material. But again, that goes back to make sure you involve your material supplier technicians to help you make the right choice on that, to make sure you're using the right overmold material.
Okay, looks like we got another one here. Can you explain a bit about what the overmolding process is or how it's done? Essentially, you're taking a substrate, which is usually going to be kind of a more rigid part. Could be a polycarbonate or an ABS or nylon, and then overmolding a secondary material on top of that. The way we do it here is it's kind of a manual process, like an insert mold process, where we'll process the substrate first and then load that into a secondary tool and shoot the second. There is a process called two-shot, where it's all kind of done at the same time within the same mold, where the injection mold press is shooting two different materials. Substrate shoots, mold rotates 180 degrees, shoots the second shot while a new substrate's being shot.
We don't do that here.
Which we don't do. We just do more of the manual process. Since we deal with low volume, that's going to be more production, high volume type work there.
You're built in two molds.
Right. Essentially.
Yes.
Hopefully that answered your question. Next one, the comment on female threading on plastic is just going on injection molded part, not on a machine part, right? Right? Yes.
Correct.
And then what is the best practice to overmold aluminum onto plastics? Into plastics. So I'm assuming overmold plastic onto aluminum substrate. If that's the case, I mean, we do quite a bit of that.
A lot of times our customers will provide us with the substrate piece, whether it be aluminum, titanium, steel, whatever
Copper.
it is, and then they require a plastic overmolded component onto that piece, which is definitely doable, and we do a lot of that.
I mean, the best practice with that is maintaining a tight tolerance part. Often we run into, if we're overmolding a metal piece, the tolerances may not be super tight. When we're dealing with a precision mold, we need to make sure that those are very consistent, not only part to part, but lot to lot, because you don't want to be changing and modifying your mold each run to basically fit that insert, because that will affect shutoffs, flashing, and all that. So just having consistent inserts that are being overmolded.
And going back to the threads, we had talked a little bit about overmolding threaded inserts. Not necessarily a plastic fill issue, but things we've run into here were inconsistencies on the thread ID. What we do is load these inserts onto a pin or a post that locates it in the tool so that when the plastic flows over, it's in the right position. Sometimes we do contend with lots of inserts that are sent to us for this purpose, and only to find out that some are small, some are large, which creates inconsistencies in the injection process. So that's just something to look out for.
Okay, I think we have one more section we're going to kind of cover here, and that's the topic of micro molding. And we run into a lot of customers that aren't aware of this concept. It's very hard to define micro molding. One way that I've seen it defined is any part that weighs less than a gram. We can do parts smaller than that or way less than that, but it's really dealing with parts that have really small features, mainly less than 10 thousandths of an inch. It just doesn't fit within the rapid manufacturing process. It's a more niche type of mold.
And it's a little, typically any small feature that's has a tight tolerance, like John said, any under 10 thousandths, very difficult to machine without it being an expensive process, more EDM required. And then simply to fill that area out and have it be consistent. A lot of these features on some of these small parts could be deemed nothing more than, flash, concentrated in a small spot. So it's,
Right.
You definitely have to watch. It's not that we can't do these types of things. It's just part specific. It takes some preemptive look at the design to assure that we can actually machine it and fill this part.
Yeah, to do parts like kind of you see at the bottom image there, I mean, they're very small, very tight tolerance parts. It's really a specialized industry when dealing with micro molding. It's special machine controls on the presses. The same goes for tooling and how they're cut and everything that kind of goes along with it. So that kind of concludes everything, and we're at the if anyone else has got any questions, we'll be happy to answer.
Okay, we do have a few questions. Thanks for submitting them in.
Let's see. Using heat stake metal inserts in a geometry which has been designed for molded in insert is affecting performance dramatically. So, if I'm understanding that correctly, it's heat staking the threaded inserts versus molding them in, does that affect performance?
It really depends on the application. If we're talking about a tool that was designed to have an overmolded insert and then be changed or adjusted to do heat staking, that's definitely something that can be done in the tooling aspect of it. But as far as the stability of the feature afterwards, I'm not sure the percentage of heat staking versus overmolding.
Yeah, the overmolding is going to be a lot cleaner process. Your inserts are going to be centered, flush, a lot cleaner look, and you're going to know the plastic's going to be molded around them instead of the inserts, heated in, the plastic cooling around them. You've got a good bond, and that insert's in nice and tight. Can you injection mold a part with a bearing? Any requirements on the bearing sealed? We've overmolded bearings before. Now, that was just on the exterior, kind of outer diameter of the bearing. Now, if there's, I'm not sure what you mean by sealed, but yeah, we can overmold a bearing. Next question, can we use an open-ended insert as a molded-in insert? Yes, you can. What would a minimum fillet be? Outside edges of a part.
That really comes down to your wall thickness, the part itself, the function, fit to another part. As Darwin said, bigger is always better on the tooling side of it.
I'd be like 20 thousandths as a minimum, or 0.5 mils would be like a smallest I prefer to have.
Okay. Have you ever overmolded magnets without them losing their strength? Yes. We try to avoid that. I know there's some magnets out there that you'll lose minimum strength, or lose some strength, but not all. We suggest if you're going to be overmolding a magnet, probably, or not overmolding it, but need a magnet in your part to insert that after post-molding. Can we reduce the gloss of a plastic part without changing the type of plastic or texture on the mold?
Sometimes your processes, your heats, and so forth will affect the finish. It just really depends on the material and the part and the film as well.
And it may not be uniform across it.
Yeah, I mean, the way you control your gloss is going to be with the texture of the tool. Now, there are high gloss materials if you're trying to get a glossier version of, say, like an ABS. Because ABS is typically not a high gloss material like a polycarbonate, but there are high gloss versions of it. But there's not necessarily textures, but surface treatments you can do to your mold to kind of matte the gloss down. Next question, how can you control not to let material get into the open side? I'm assuming you're referring to the open insert. It's the core pin that the insert sits on, so that insert seals onto the core pin and will block plastic from filling the inside of the insert.
And there would be a shoulder on the pin itself, which would seal off on the end of it. And as long as that's nice and tight, you're good. You won't get any leakage into your part, whether it's an open end or a thread, whichever.
Okay, here's another question. When designing a part with outside zero draft and we know that slides are going to be used, is there anything we should be looking at during the design phase? With that, you probably want to figure out where you're going to hide your parting where your slides
come into the part.
Because, it's...
Try to get them on the corners.
Yeah, try to do corners or hide them within a rad, especially if this is a cosmetic part. If it's not, I guess you really don't have to worry about it. A good question.
we have just a few more questions. Any more questions, please send them to us. Thanks for all the questions today. A few more. What type of files do you use? What do you work with?
Here at Eccentric, we work with like STEP, IGES, SolidWorks.
Okay. Next question. Overall, what are typically your toughest design challenges concerning? Is there any one area that seems to be of most concern?
Well, we draft is a huge issue with several designs for sure.
Small radiuses.
Definitely that. Yeah. The wall thickness. I mean, a lot
Yeah,
of what
it's-
we've gone over here. These are a lot of generalities in design that we tend to have to work around or get some concessions from the customers to make a better part, make a better mold.
Yeah, I would say top two would be draft and wall thickness and the transitions. Just doing those correctly, following the molding guidelines for those would probably be the top two for me.
Okay, last question for today. I'm actually sorry, we have a few more here. Apologize.
What is the best person for you to have a conversation about design with? Mechanical engineer? Question mark. I guess if that's, I'm not sure if that's referring to you. You can call us anytime. We'll be happy to review your design and talk through it with one of our technical account managers. We can review your parts, do multiple analysis and all that, and give you feedback. Hopefully that answered your question. Next one, do you make all your tools in-house? And if so, how many machining centers do you have? We do make all our tools in-house. We have 2 facilities here in Michigan. And right now, I think we're about 12 machining centers on top of all our other machining equipment. If all faces are cosmetic, should the part line then be aligned to the edge fillet or on the fillet? It would be probably the edge.
The transition.
Yeah, wherever the transition is, you want to kind of hide that parting line there.
Okay, any more final questions for today? All right, thank you for all the questions. Thank you for joining us at this webinar. For any questions or interest in Eccentric products, please visit our website or social channels or contact us directly at the number and the email listed on your screens. Thank you for joining us today. We wish everybody a good afternoon.
Thanks, everybody.
Thank you.